Well, hi and welcome to my shop here this morning. Yesterday's video was just me testing the tubes in the radio, and I found two of them, three of them in fact, that need to be replaced. One of the new ones is here. The other two replacements are sitting right here. 6 JK-66 IF amplifier and a 6 JK-67. These tubes test very good. There we are. So we're going to turn on the radio and just see how it works now with a couple of better tubes in it. But first, here it is, man, the Bug Blaster Mark 1. This guy has done away with a couple of bugs now. So I had to go chase him down on my deck because apparently snapping this once or twice in my house has scared all the ants out of my house. Usually I have one or two black ants wandering around, but just for the thrill and excitement. The Bug Blaster. Wow. Wow. Yes, and it kills them dead. Let me tell you. Okay. Now, just double check here. So this is still only plugged in with the audio part of the cord. Everything else, so the antenna is plugged in. Righto. Here we go. So the surprising thing to me was this tube, the output tube, had a short between the cathode and the heater. And I would have thought that at least that's what my tube tester reported. I would think that that would cause some kind of terrible problem in the radio, especially with hum. But there certainly was no hum in this radio. So how you can have a short there and it has no bearing on the operation, a little bit surprising to me, but that seemed to be the case. Now, before I say too much, let's turn this guy up. Okay, it's working. We're on band A, we're on the AM band. We're plugged into the antenna. Yikes, what is doing that? So this noise, which is new to my shop, is very strong, and it's right on top of some of the stations that I like to tune to. About the only thing I've got going in here right now that's new is the soldering iron. It's not relatively new, but I'm going to just cut the power on it. Huh. Well, I don't know, I could go on forever hunting these things down. That's really... You know what? I don't have my radio on full voltage here. Ooh. think we got more volume. I don't think there's any doubt of that. Performance is really no different. It seems to be no different. I pick up one station, 680. I think 640 is right there. 590 would be down around here somewhere. Okay, I think the next stage here is to do an alignment on the radio now. I'm not sure there's too much more I can do in terms of parts and whatnot. So we'll do the alignment and we'll see if that kind of brings back the AM. This radio stands a really good chance of being an excellent AM receiver, even in the face of all this noise. This should be able to grab the stations quite effectively. So let's see if we can make it do that. So X-axis here. So what we're going to do before we do that, we're going to attach the 3 other wires here to this piece. Okay, so if I put this up on its side, it's got a couple of problems with the way it's shaped and wheels touching and other stuff. Flipping it onto its face is out of the question. Flipping it right upside down is not going to help. Flipping it on its back is probably where I want to go. Flipping it onto this. But it's not going to sit on here. It's got this cord, it's got these things. These things are a different distance. So what I'm hoping to do here is use some blocks. These are really solid. On this radio, these are really, really solid, so I'm not worried about relying on those. Laying on the cord, what does it really matter? Makes it unstable. So I put 2 stabilizing blocks here, put 1 here, and these, this has to be higher now. See, all that time I played with blocks at my grandparents' place was paid off here. It's paid off. Something like that. Okay, enough wire here. See if my, there we go. That's a lot of weight hanging on those cans. I don't think there's much else I can do here. Just happen to have the size block. Okay, so good. Okay, so I've got a block now. Hard to see all these blocks I've got in here, but I've actually got it supported right from the transformer now. It's not on these. It's not on the cans anymore. That's pretty solid. That's great. That's about the best I've ever had one of these radios set up in here. Take the brake off. That's fantastic. So we can get at the bottom of the 2 cans. They're down here, here and here. perfect. Pretty perfect. Oh, okay, here we go. Oh, okay, that just worked out great. Let's carry on with the IF. We'll do the IF alignment here. Get the set on. Volume down. All looks good. Yeah, one light's quit here. Why? I think it burned out. Okay, that's working. Now we want to pump in. We need to read the instructions here. That's for sure. Okay, so I took a look through the manual, discovered the what it's recommending, of course, is the signal injection be done just before the stage you're going to adjust. So we're going to adjust the output side of the IF. So that's one IF can here, there's another IF can there, there's the tube in between. So we want to adjust this last can, feeding the signal into this tube on the grid of this tube. No, the last can's over here. This is the first can, amplifier, last can, grid coming in on this green wire, which I'm going to tap in a minute, see what it sounds like. I'm tapping right now. Not a lot of noise. So what it wants you to use, the manual requires a 0.1 capacitor. Now there's no voltage on here, but right here is the 120 volts coming into this radio. Right here, there's the core. I stick my fingers in there, and yeah, that doesn't sound like a good idea to me. So I think we're going to cut the power briefly. Reach in here now. This doesn't feel right. It's come loose. Okay, radio's off. On here. There we go. Okay, this will be the signal generator. Switch it on. So we're going to want the signal generator at 455. Roughly. Okay, that's a moderate signal coming out, 400 hertz tone on it. We should be able to hear. As soon as I connect it up, volume up. Oh, power on, power on. That's a good thing to do. Power on. Good. All normal. Now that's quieted the radio because this in effect is pretty much a short circuit. This is a 50 ohm circuit back to my signal generator. So that's what's just killed. Whatever was on that grid has been killed. But now I'm going to stick my own signal on there. And actually my own signal's already there. I'm having a little bit of trouble seeing that. There we are. 435. We'll take it up past 455. And turn the volume up here on the radio. Anybody hear anything? I didn't hear anything. Oh. That's 413. Wow. Okay. Let me give it a little more juice. Okay, we're going to hear this. So the IF is way off on this radio. At least the first part. Okay, one thing I haven't done yet is I haven't hooked up a meter. There's a couple ways we can do this. One is we can hook it up onto the AVC line if we want. It's actually my preferred way of doing it. Or, as the manual suggests, hook it up to the voice coil of the speaker, which is my not preferred way of doing it, because then we have to listen to it. So why don't we try the AVC voltage? And where are we going to get that now? AVC, it's going to come on the schematic. Let's look at the schematic here. Here we are. Bingo, just like that. Okay, so we're over here looking at the detector. There's the two little diodes there. Okay, and there's a DC building up. What I'm looking for is the, here's the volume control. Ooh, sneaky stuff going down through here. So my guess is the DC will be present on the top of the volume control. So I can pick it off there. I can pick the AVC voltage off at the top of the volume control, which is always easy to find. Then we just monitor that voltage. Okay, that's all there is to that. Otherwise I gotta find these wires and everything like that. It's not. The meter I'm going to use for this, simply because of its convenience, I'm going to use this. I'll use this guy here. I'm on DC minus. It's a negative voltage. The rectifier, when it rectifies the IF signal, can produce either a DC positive or DC negative voltage depending upon which way you wire it. So they wire it to produce a negative voltage relative to the chassis, and they use that voltage to control the volume of the set, which I have explained far too many times. So we want to watch the AVC voltage relative to the chassis, and we think this is on DC. We think it's on the top of the volume control, and of course they've located the pins of the volume control in behind here. So this turns out this isn't the easiest thing. Boy, oh boy, oh boy. Let's bring in the crane. So the three are kind of up and behind here. One of them is right. So I can see the capacitor that's on the center terminal So one outside one. Pretty sure I can see the ground connection quite clearly. The one I'm after is right on the front there, easy to get to. So I think it's simply, let me look with my own eyes here. Yeah, it's a small negative voltage there. So let me clip lead my voltmeter to that spot. Top of the volume control. Operating set here. Okay, good on that. So on the 5-volt scale, we're reading a half a volt here right now. I'm going to tune the radio and this should move around if all has been done. Things have worked out as expected. So I'll turn it up a bit so we can hear it. Oh, a buzzy hum has come into it. No, nothing happening there. What have I grabbed? That didn't work out at all. Okay, so how come it's even got any voltage on it? Let me just disconnect here. So negative steady state voltage on it. Now there's a chance. Oh, you know what it could be? So I'm feeding the IF signal still into it. So tuning the radio didn't do anything because with the signal generator connected, that's all blocked. So I'll disconnect the signal generator. We'll probably watch that voltage drop. Oh my, that was a painful mistake. Let's try that again. Sorry about that. Okay, now we'll watch this thing. There we go. Excellent. Okay, putting this wire back up. Yeah, blew my ears off there. I'm pretty sure YouTube's got obviously some kind of limitation, volume control limitation of some sort. So your ears are probably intact, but mine are not so good. Where are we at now? We're all set to go. Got the meter hooked up to there. Let me just get this camera into a better position here. Okay, there's a close-up look. Let me just change the much movement there, right? It's a fairly weak signal, I believe. That's me changing the signal generator frequency. Okay, now there we go. So you can still see the meter. And we're ready to go here. Almost. Okay, so we want to do this IF here. This is the bottom. I got a better tool. Somewhere I do. Let's try that. Okay, we're on. Yep, turns easily. Okay, so now we want to watch the meter, but we want to bring this to 455. Okay, let me max this. Okay, now we go on the top. The same can. Goodness knows I can't swing this all that way. Okay, we're in. We're watching the meter again. This guy's way out. Hold on a second here. What's happening? Uh-oh. Uh-oh, 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 uh-oh. Okay, something funny going on here. The slug is disappearing into the can. So, this slug has come way out, and the other slug, I've turned it into the point where it's falling into the can. I can't even grip it anymore. What's that? What's that say? Sometimes there's more than one peak in these things. So I'm going to put these into kind of what I would call a neutral position, where I would kind of think the starting point would be. Push this guy way back. Way back here. To me, that would be the starting point. Now the other one, I gotta try to dig it out. Ay, ay, ay. I can't even see back there anymore. Okay. So there's something's definitely awry here. So that can is now adjusted, kind of what I would call kind of the starting point, or I just put the slugs kind of in the middle of their range as best I could. Can't hear a thing. There it is. But by now the tuning is just way off. It's way down around 400. So, what could that indicate? It could indicate, so it's a coil and capacitor combination that's resonant in there. And I'm adjusting the slug in the coil to bring it into, to calibrate it. Either the coil has gone defective, shorted turns or something of that sort, or the most likely thing is there's a capacitor that's gone out of whack. Some of these radios, the capacitor I'm talking about is hidden right inside the can of the IF. Others, it's not the case. They're up on here. Let's sort that out first. And yikes! Let's look in the schematic and see just which parts could be resonators. Could be important in controlling the resonant point of the circuits of the IF. Got it? Have I got it? I think I got it. Okay, let's take a look at the schematic here. I'm just going to show it on camera here. I think that'll be good enough for what I need to show. So right now what we are fooling around with is this transformer here. So this coil is the primary's resonant with that capacitor, and likewise on this side this coil is resonant with this capacitor, or you're trying to make it resonate at 455 by adjusting a slug inside these two coils. In my case, these will set up at around 400 instead of 455. 455, these guys are the slugs are coming right out, basically. So what could throw it off? Why both? Why? Well, I don't know about both. Well, what could throw it off is if this capacitor, its capacitance has drifted, or this one, or both. I don't think this guy can cause a problem in that respect. 100 picofarad to ground. I think it's going to be these guys in particular. With them in the circuit, there's no way to test them with them in the circuit other than to kind of do the alignment and see it not work. I suppose that's kind of a test. So I got to find these guys. Now either they're in the can or they're not in the can. C18, C19. Let's see C18 and let's see C19. Hey, got this diagram here. This is going to help a lot. Okay, so let's get orienting. So here we are. The tube here is this is the second IF grid. So the signal's coming out of here onto this grid wire up here, and then coming out, heading through this. So this is the transformer we're working on. Yeah, the one in the corner. That's right. This over. Yeah, definitely. Ooh, what's that say? L11 primary adjust. Yeah. Oh, good. It's telling you that this the primary side is down here underneath, and the secondary side must be up on top. 455. There's no question it's 455. I started wondering about that. So, ooh, what's it saying here? It's got C18, C19, C18, C19. But you see, they normally label the component body with its number. There's no component body. And L19, L11, L19. They're inside the can. They are inside the can. Ay, 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 ay. They're inside the can. The chances of them having drifted off is so low on these capacitors. What else could be wrong? Something else must be wrong. Hopefully something else is wrong. So we got some resistors here. A couple other capacitors here and there. These two resistors, what are they doing? R8 and R10. R8 and R10. What are they up to? Could they affect this? I don't know. Offhand. Let's see. Here's the transformer again. R8. There's R10. That's not going to have any effect on. And R7. R12. R8 way down here. No. Well, what if these are really, well, what could they do? They could go open. I've read the AVC, or I'm reading the AVC up here though, I'm not reading it down here. I just don't think these resistors can throw the tuning of an IF can way off up here. I think we're just something right in here. So this guy's accessible. So I'm just looking for any way to get away from taking the can apart and going inside after these, because I'm just willing to bet there's nothing wrong with them. I'm just totally wrong in my assessment. They do an awful lot of work to get at them for nothing. Maybe even introduce more problems. What else could it be? I've never really had one go off like this. Hey, what about the other one? Let's check the other one. See if we got double the trouble here. So it is possible to tune the IF up at an incorrect IF frequency and then compensate with the oscillator control and the pointer setting on the string. The problem with that is it won't be very linear across the dial. The dial movement, I don't think, will match the markings exactly. It's going to match in one spot only, and the rest of it's going to be a little off if you do something like that. But that's where we might end up with this radio. So how about the connection that I've made? Disturbing, no, it can't be. I've made it onto the grid of this tube, and then I'm working on this transformer over here. So there's no way this connection is throwing the stuff off over here. What about an incorrect part? So there's a number of parts. Where am I pointing here? There's a number of parts over here. There's one I replaced right there. Only one. I didn't replace any of those black ones. There's one underneath here. You can't even see it. One there. I feel some heat coming out of this. I think I need to verify that these capacitors are correct. There's another one sitting right here. What's that one doing? Those can't throw off the IF tuning though. Can they? I don't think so. I just really think it's just got to be these two guys. Or some problem with the coil itself. And maybe if this was way off, maybe this one, maybe could do something like that. What if you put a solid ground on here? It mess things up pretty thoroughly, I imagine. This is coming off. So this is coming off the diodes here. My experience with these, and I'm not saying this is true, but kind of the feeling I get is when you adjust the primary, you're changing the tuning. And then when you adjust the secondary, you're simply making it match up with the primary to get maximum out. That's what I believe you're doing. So if that's the case, you'd always want to do the primary side first, which is what I was doing. I did the primary side first. So if that's the case, then the primary side is the one that's off. I have to tune it way down to hit the resonant point. But this one, I then have to match it to get any signal to come out. So it really, what I've done doesn't really indicate the secondary is in trouble. It indicates the primary is in trouble. The primary involves this tube, and then you're just into a whole bunch of radio down here of all sorts. There's not a lot on the primary that could cause a resonance variation. Like mainly got to be that capacitor. So what we can do here, we can put a little extra capacitance in there. So it's supposed to be 56. We can put a little extra across these terminals. Now let's think about that. If it's tuning low, oh my god, I can never figure this out. If it's tuning low, I think there's not enough capacitor or not enough inductor. You're pulling the slug out. The slug is tuned to an extreme. You're trying to reduce the inductance. Think about this. So I'm I thought doing the IF alignment would be a real easy thing. It usually is. I hope I'm not making a big deal out of nothing. Hey, what's the matter here? should see 2.2 ohms here. 2.2 mega ohms. And what are we seeing? Oh, this is 10K. Maybe I'm in parallel. Maybe I didn't. Oh, what's going on? 10K across that resistor. How do we get that? So we're measuring. So this guy's got lots of capacitors across him, probably. There's another 2.2 down here. How do you get down to 10K? I'm not sure how that can possibly happen. 10K. Volume control? Makes no difference on the reading there, I think. Definitely. R8? Maybe I'm on the wrong resistor. R9, I'm on the wrong resistor here. R8, R9. R9. Where are you? Saw you before. There's R9. 10K. There we go. Okay, so, okay. Take it all back. This is probably supplying screens. Sure enough, it's supplying screens. Okay, I'm off on the wrong thing entirely. Well, that answers the question, what's that great big high wattage resistor doing there? Doing the screen thing. So that's very common. High wattage screen resistors. Measured 10K just fine. So that didn't work out. Well, what about this other one? What about this guy? R8. R8, he's really involved with that thing. R8. And R8 is supposed to be kind of hard to see there. That's what it's supposed to be. Should be right in here somewhere. Should be on the inboard side, right beside the capacitor, according to this. Connected to B and E. You can find it that way too. Here, oh there, I just see the tip of it. Can you just see it? Just a little red tip of it right there. So the capacitor here, there's one right underneath it, and then underneath that is that resistor. Okay, I know where it is now. Its value is supposed to be 22. Wait a minute. R8. 2.2 mega ohms, and it, wow, trying to get in there and read that. Oh my gosh, can't see anything in there. Well, I can see one terminal. Oh, I see them both. Okay, I think I can get in there. Yeah, I can get in there and read that. $22K, and it's supposed to be oh, I got the right one. be 2.2 mega ohms. Oh my gosh, look what's happened on the screen here. Sorry about that. So 22K. Now, have I really got it across that resistor, or am I making a mistake? Let me look and see. So, quite clearly it's across the resistor. Now, what resistor? The resistor in there is I would say it's red, orange. And that would be R10, perhaps. Okay, so we're looking for R8. I've got to go all over this again. R8, 2.2 mega ohms. I think I'm on R10. Because that should really be red, green, shouldn't it? So R10 is right off one of the pins of the coil. Yeah, that's it. So we're reading R10. 22 is just fine. Now we got to find this 22. R8. Okay, so R8. What's going on here? Oh, I see. R10 and R8 are right side by side. That's why I'm having trouble here on this. R10 and R8. So I've just picked off R10, thinking it was R8. So R8 is right in here. It's right in there, somewhere. Where would that be? Supposedly, so if I put this in the right angle, supposedly R8 is right here. Right here. So there's R9. R8, right in the shadow here. Where are you, R8? There it is. I see him. He's there. And I see the green. I do see the green. Okay, let's just try to get on that one. I think it's as simple as this. Let's see what we got. .7. Okay, so paralleling circuits would only reduce the reading below the goal. Okay, so let's just checking the lead connections there. 1 is correct, 2 is correct. That's definitely across that resistor. It's supposed to be 2.2 and it's 2.7. Is not going to really make a difference. Had a little bit there. So if this goes from 2.2 to 2.7, that's 500. That's 500 in 2200. So that's like a 20% change. We have trouble with this coil. The 2.2 I just read is not even connected to it, for crying out. Yes it is, yes it is, yes it is, yes it is. On the other side of the 10. It's on the other side of R10. Hard to see how anything about this can possibly affect the resonance of this. So I think 2.7, 2.2 is probably not making much difference of any sort. Look at this, is looking into very high impedance circuits here. So what to do? So we'll get it back to why I can't get this thing to resonate at the proper frequency. It comes back to these capacitors inside the can. Okay, let's take a look at taking the can apart. Let's see what's involved in that. Give me a second here to reset everything. Oh, for crying out loud. So we can actually start by looking down underneath here, and I can see 2 threaded posts coming through with nuts on them. Pretty sure I'd loosen these nuts off, the can will come off the top clean. That's my hope. Tiny. Okay. See the top wiggling? That's not good. We don't want that. So there's a spring catch here, which we're going to remove because that's probably locking in the guts in an undesirable way. Where's my strong pliers? I think they may have gone outdoors. I don't remember taking them outside. Okay, alternate strong pliers. Okay, springs off. Oh boy. So down here, I see a rivet to this circuit board. And what that's telling me is you cannot separate this can from what's inside the can. You cannot do it. The whole plan has gone down the drain here. Really? So these rivets are holding the metal threaded part. Maybe. No, it doesn't want to go at all. Really? It just... Maybe it looks like you could just get them. Maybe it's stuck. Maybe it's stuck and I can free it up here. Yikes. Nothing moving. My cat has come to my rescue here. We're really in a spot. The can has to come off. This is where the radio goes from working pretty good to completely ruined if I do this wrong. Did I miss some lock up in here? I'm misinterpreting what these are. No, I can see it underneath. I know, Peanut, it's sad. It's sad in here too. That's moving. So that's moving relative to the threads, but the whole deal is not moving. Oh my gosh. I've taken a number of these apart. I've never had one that was like permanently made. Yeah, don't do that, Jim. You'll wreck it. Trying the same thing over and over. Why would it be stuck if it's not? If it's supposed to come out, what would make it stick? What would hold it in? What would hold it in? These. There's nothing else on this cam. There's nothing else going on here. To desolder all the wires, pull the whole thing out, and examine it. I don't want to do that. You know, this guy put this part on here. Did he do the right thing? Did he do the right thing here? Yeah, I know. So it's been raining outside today, and the cats are a little upset. Yeah. Yeah, you know what? You're right, Peanut. Time for a break here. While I ponder this before I make a big mistake and do a lot of extra work, cause problems, and don't fix anything. Yeah, let's take a little break here. Right on. He's such a serious cat. Look at this guy. Yeah. I know. Okay. Gotta go help him out. Yeah, good to stop for a bit. Getting into a real frustrating corner here. Yeah, I'm coming. Okay, I think that clarifies things quite nicely here. So, C16, it appears to be connected to this transformer, but really it's just a dummy terminal here. So C16, R8 come together at this point, and then there's a wire, this yellow one. It comes up here and ties to D on here, and that is where it is shown on the schematic. So I've just been thrown off by these connection points. They don't do anything else. So now if we take a look at this, we see upside down L12 and L12. So these two connections must be across L12. And you see C19 and C19 also. So L12, C19 form the resonant circuit right in here. Can we not try to measure? Can I not just click right on these terminals and try to see if there's a resonant point here? How exactly would I do that? I've kind of already done that just using the radio itself to supply the signals. So I can't imagine that's going to get any different. Okay, so really what I was doing was verifying that the correct size of components have been added, thinking that especially if they're connected to these terminals then they're going to affect this thing, but they're not, because the terminals are fake terminals. So really, well, look, here's R10 connected to one of the not fake terminals. Here's R15 on a not fake terminal. Lots of stuff hooked up here. R9. So I could check these. I think I did check R9. I haven't checked R15. R15 is coming from a plate here. R15. Wow, let's take a look. So R15 should be sitting right here. There it is. Looks like 47. Looks like 470K is what it looks like. R15. So R15 somewhere in here. Find them all but 15. Come on. You're looking right at it, are you? R15. Come on. R15's cooked up to A on 2. There it is, 15. 470. Okay, just as I thought. Is it really? 470K? It's a slow process, boy. A lot of wires coming together right in there. So that says 1 megohm. That's quite a change from 470. And there's another 470K right here too. So this one's coming in at a megohm. I'm going to throw off the plate. Throw something off. How could I possibly read this? I'm reading right across it. No question about it. Reading right across the resistor. So it can only read 470K or more, or less rather. So if it's reading more, it's got to be more. So this one's got to go. Now how can that possibly? Well, maybe it can. I don't think so though. Throw off the resonance of the first transformer. But that's quite a ways out. 470 or double its. Double it. Look at the difficulty getting in there. Okay, so I've replaced the resistor here, and I've also gone ahead and replaced this capacitor here with this one. Other capacitors are the right size and the right position. I think we're good to go at this point. So did this make any difference to the resonance point in the IF? I certainly wouldn't bet on it. So where are we? Set. Plug it in. Everything's ready here. Wow. Well, I was fast on the draw there, wasn't I? Loads of volume. Let's get off that. How's it picking up stations? Can it pick up a station? Picking up lots of stuff, no station. Okay, so we're going to hook up the signal generator here. Silence. The signal generator is running at, let me change the lighting here. Maybe you can see it a little better. $461. What do we hear? It's audible, but you got to turn it right up. Okay, so now I'm going to there we go. Still at 410. Way off from 455. And I'm not even going to attempt to tune it in at 455 because it would be stupid if I didn't try. I should try. It's in the middle of making a pretty good assumption there. It's not. There we are. Okay, so we're in place. So we're at 452 over here, and leave it there. It's quieter. So we're coming way out here again. I don't like it. Son of a gun. So I didn't think that would help, but I was secretly really hoping that would change the change that IF. Okay, I think we're going to stop at this point because the whole morning is gone. A little bit rainy today, but I don't know what to think. I'm going to have to take that can out of there, take the whole thing apart somehow, get inside there, fiddle with the capacitors that are inside that can, the IF can. That's really not an attractive. That's not very attractive. Okay, well, thanks for watching, and carry on tomorrow.